Alright, so we're starting with Unit 7, Day 6 today. I do want to work through this warm-up with you, though, just to practice from what we did in Day 5, converting from polar to rectangular, rectangular to polar. So on the first one, they give us an ordered pair, and we want to change this to polar. So we need r and theta, which means this is in rectangular, so this is x and y. So remember we had a couple formulas that we could use for this. So if we're trying to go from our rectangular point to our polar point, one equation we're going to use is x squared plus y squared equals r squared. So our x is -3, our y is -3, and that's equal to r squared. So we're going to have 9 plus 9 equals r squared. So our radius will be the square root of 18. Alright, so then the other formula, if you remember, going from rectangular to polar, we used was tangent theta equals y over x. So we're going to have tangent theta equals y, which is -3, over x, which is -3. So this is equivalent to saying -1 over -1. So guys, because they are both negative there, we do have to worry about our square root, or sorry, we have to worry about what quadrant we're in. So tangent -1 over -1, that's the same thing as when you have the negative square root of 2 over 2. So if you look at 5 pi over 4, that's where we have this negative square root of 2 over 2 at both places. So the theta value that goes with this is 5 pi over 4. So my point in polar form is the square root of 18 and 5 pi over 4. Remember, polar points can be written in an infinite number of ways. So if you wanted to rewrite it, the one that's opposite from this, so square root of 18, remember if we want to do the opposite, we make it negative. So if you look at your unit circle, 5 pi over 4 is directly across from pi over 4. So negative square root of 18 and pi over 4 could also be another way you could rewrite that polar point. So that's how you work with number 1. So let's take a look at number 2. So for number 2, we want to convert polar into rectangular. So we have polar, which means this is r and this is theta, and we need x and y. Okay, so this had two specific formulas you're going to use. We have x equals r cosine theta. So x equals, the r value is 4, cosine of 3 pi over 4. So let me pull the unit circle back up. So if we look at 3 pi over 4, our x value, our cosine value, is negative square root of 2 over 2. So this will leave us with -2 square root of 2 for my x value. And then we have another formula for the y value. The y value, we use y equals r sine theta. So y equals r, which is 4, sine of 3 pi over 4. So using our unit circle at 3 pi over 4, this is at positive square root of 2 over 2. So the y value of the coordinate is going to be positive 2 square root of 2. So the rectangular ordered pair is -2 square root of 2 and 2 square root of 2. And remember, that's the only possible way to write rectangular. There's always only one way to write that. Alright, for number 3 and 4, we're going to be looking at the equations, changing them from rectangular to polar. So take a look at number 3. That. Okay, we're given r equals 3 cosine theta. We need to change this to rectangular, so we're looking for x's and y's. So one way to do this is, if you remember, we know we know x equals r cosine theta. So another way to rewrite cosine is this x over r. So I would replace this cosine trig function with x over r. So now we've gotten rid of theta. Then to get our r's combined, I'm going to multiply both sides by r. So we'll have r squared equals, these will cancel, and we just get 3x. So then we know r squared is x squared plus y squared, according to one of our formulas. So that is in rectangular form because we only have x's and y's, but we're going to put it in standard form because we know it's going to be a circle. So if I subtract 3x over and leave a blank so I can complete the square, we won't have to do it for y squared because it doesn't have any y values that go with it. So we're going to have b over 2, so negative 3 over 2 squared on both blanks. So for my x's, it's going to be x minus 3/2 squared. Remember the shortcut, you can just keep the inside part. Plus y squared. Negative 3 squared is 9. 2 squared is 4. So this would be your standard form, which is in rectangular form with x's and y's for that circle. And we will be graphing these polar functions today, so all that will come into play and you'll be able to see how the circle works out. Alright, last one on the warm-up, and then we'll get into the new stuff. So we have xy equals 4. So the goal here is to get in polar, so we need r's and thetas. Remember that you either want to solve for r or you want to solve for r squared. It just depends on the problem. So we know that x is equivalent to r cosine theta. And we know that y is equivalent to r sine theta. And it says that's equal to 4. So this is multiplying, so r times r is r squared. So this is going to be a case where we solve for r squared because we have it. So r squared is 4 divided by cosine theta sine theta. All that is not wrong. There's a better way to write it. So because these are multiplied at the bottom here, you can actually move them to the top. So 1 over cosine is secant, so we could say 4 secant theta. 1 over sine is cosecant theta. So you could rewrite your final answer as the r squared equals 4 secant theta and cosecant theta. Alright, so that was just a little bit of review on that. Okay, so we're going to start with, this will take 2 days, so we'll do polar graphs. Today we're going to focus on circles and rose curves, and then on tomorrow you will be focusing on 2 other shapes, so we'll have lemniscates and limicons. And cardioids. We'll be looking at cardioids. So, with this, first thing we need to look at is we're going to be using a polar graph because these are going to be polar equations. So sometimes these are hard, like you don't actually have the notes printed off. So if you don't have the notes printed off, just draw it the best you can. I'm going to try to draw everything on here, so it might not be the best graphs for you to look at, but that way you can see like on the graph what it's supposed to look like. So if we take a look at what it says, circles is r equals k. So if you ever have r, which you know stands for radius, equals a number, that is going to be a circle. So for example, you have r equals 2, that means the radius is 2 and it's going to be a circle. This could also be a negative number, so we could have r equals negative 5, that will also be a circle. So it says where k is a constant will be graphed as a circle centered at the origin or the pole. So it's going to be centered at the pole because we're talking about polar. Remember, pole just means the origin. And the radius will be the absolute value of k. So even though it says r equals negative 5, the radius is just going to be 5. Something that we really need to make sure we note is that it will take 2 pi radians to trace out a circle in this form. So what this is going to mean is when we draw our circle, this 2 pi radians means that it's going to take up the entire unit circle for us to graph this. Okay, 2 pi is an entire unit circle, so it'll take up the whole entire graph. Okay, so first example, and I'm going to write the information on here, and then I will graph it on there. So we're looking at r equals 4. So I want to write some things about this. Because this is r equals just a number, we know this shape is going to be a circle. We know that the radius of this circle is going to be 4. We know because it's just r equals 4, it's going to be centered at the pole. And we know because it's r equals 4, it's going to take 2 pi to trace this circle. So it's going to take the entire unit circle to graph. Alright, so when you're graphing this, so take a look at this graph over here. We're going to start at the pole. The radius is 4, so you just want to go up 4 spaces. So we'll have a dot here. And then you want to go to the right 4 spaces, down 4 spaces, and you want to go over to the left 4 spaces. So I'm going to try to draw this with my finger, a little bit easier. These are not going to be pretty, but it's horrible. Let me try that again. If you're in my class, you know that I can't draw this stuff that great to start out with, so it's not really good on the computer. But we had your points here, 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 and here. And then if you draw in your circle, this is a little bit better. I pretty much just go on the outside here. So that's a little bit better. So r equals 4, mainly looking at your points here, but you can graph that part there. Okay, so looking at the next one, we have r equals -3. So it's just r equals -3, so this is in polar form. Because it's just r equals a number, we know this shape is going to be a circle. We know that the radius of this circle is going to be 3. We know that because it's just r equals a number, it's going to be centered at the pole. And because it's r equals a number, it's going to take 2 pi, or the whole unit circle, to trace this. Alright, so here we go again. This time it's still centered at the pole. Our radius is 3, so you're just counting up 3 spaces this time. 3 spaces over. Now you can draw as many dots as you want here, but if you just do the main part, you can get it. So then, if you just trace your circle. So the main thing to note is that you know that r equals a number is going to be a circle. It's going to be centered at the pole, and it's going to take 2 pi radians to trace, because that would be your entire unit circle. So I'm going to stop on the video for this one, but we're going to look at some other ways that circles can be written in polar form on the next one.